In part one of this podcast, we're going to look at the idea of solving compound inequalities. When we think of a compound sentence in the English language, we know that there is some kind of joining word that joins two complete sentences into one thought. So it is with inequalities. The two words that we focus on is the idea of and as well as the idea of or. So our two examples, we'll focus on those first, and then in the second part of this podcast, we'll look at how that is related to the idea of solving absolute value inequalities. Example 1 is looking at the idea of using and as our compound linking word. Notice first of all that the word is based on sometimes writing the inequality as a shorthand. Notice that this will have two inequality symbols in it. They need to be facing in the same direction, and in order to solve it, we will first practice splitting this into two statements joined by the word and. Only the and word can be written as one continuous shorthand statement. Once we have rewritten this as two parts, then we go about solving that like any other inequality. The result of each part of that is to identify our border points. -4 must be less than x, and it is the case that x is less than 7. So on our graph, we are going to identify the borders as -4 and also 7. Next, we will identify the correct solution. What values are greater than -4? Well, it would start at the 4 location as a border, and then if we thought about some numbers, for instance, to the right like 0, we would say yes, 0 is certainly greater than -4, and the resulting arrows with the line would cover all possible true statements. The second part of our compound states that x must be less than 7. Again, less than or equal to means that we will begin with a solid dot, and again testing that 0, well, 0 is less than 7, so going to the left would result in a true statement. Notice that I identified these areas above the intended number line, because it's on this line that I finally bring the compound together. In order to be in both sets, it would be the case then that it would start at -4, and the two colors then end at 7, and so on the number line I would indicate that the area between -4 and 7 is in fact our solution set. Next, we'll consider a compound using the word or, as in exercise 8. As in example 1, we individually solve each inequality with the resulting d is greater than -2, ready to then graph on our number line. Well, this time it's strictly greater than, so I will have a hollow circle, and thinking of the test point 0, that line would extend to the right. The second inequality tells me that d is less than 3. Again, 3 not being included is hollow, and less than extends to the left. To arrive at my final answer that I'll place on the number line, I need to think about what the word or means. It means that the number in either the purple color or the brown color satisfies this compound statement. Well, noticing then that this extends infinitely to the left and all the way infinitely to the right, at every point any number is under one of the colors, I come to the conclusion that my answer is really the set of all real numbers. Now contrast that with the previous example, and meant it had to be under both colors, included in both sets, or means it can be included in either set. So thinking about or as either color and as both colors helps us to visualize and come to the correct solution. The final answer here then would be the words all real numbers. In this case, the case of and, we would probably want to say it's the set of all x such that -4 less than or equal to x, which is less than or equal to 7. There is our solution set.